So, very good afternoon. Namaskar to one and all dear participants. Myself, Abhishek Danodia, and I'm going to deliver a lecture on crop condition and drought assessment. So, during this entire lecture, I will discuss the remote sensing part, the very fundamental remote sensing part related to the vegetation, how to compute, and which specific band we are used for generation of spectral vegetation indices, how we can use remote sensing for crop condition and various research point of research part. Then I will discuss the part of drought, fundamental definitions and their types, how India Meteorological Department they monitor drought using some sophisticated ground-based information, and how remote sensing can be used for various application agriculture drought assessment. Related to that, various case study, I will thoroughly discuss all the part in terms of their methodology and their results, how we incorporate and how we interpret the result in the same theme of agriculture drought assessment part. Then I will tell you and define you related to Government of India initiative in the same, the project name, the NEDEMS, and now the MNCFC will take care about the drought assessment and monitoring part, agriculture drought specific. So I will discuss those, their methodology, their work, drought manual, all that required and defined material. Then I will discuss the global products. What are the various kind of global products readily available and freely available? Using that, you can directly visualize, you can analyze, and you can download the product also. And for the particular area specific, for the region specific, and you can further use for part of research as well as the understanding. So I'm very first start the part of remote sensing of vegetation, like this figure, the figure in this defined in the slide, which is a kind of scatter plot of reflectance with respect to wavelength on x-axis, and that very precisely define the signature, or you can say the reflectance curve for a stress vegetation and healthy vegetation. If we make a comparison with respect to healthy vegetation and stress vegetation, there is a clear-cut difference at a defined wavelength. And these defined wavelength we can interpret from like the band, red band wavelength or near infrared wavelength. So using those two band specific wavelength, red and near infrared band specifically, we can use and we can generate various kind of spectral vegetation indices. And among all various kind of spectral indices, NDVI and VCI, which is mostly used spectral vegetation indices for crop condition and drought assessment. So related to the theory point, as I also mentioned in the same slide, like how much reflection or you can say reflectance are there in case of normal healthy vegetation, the NIR has higher side of reflectance, while the red band has least because of the absorption by the leaf pigment. And while the higher side of reflectance in the NIR region for the healthy vegetation is because of the leaf structure. So with a contrast difference because of the leaf structure and leaf pigment in the specifically band of near infrared and red band, and with contemporary, if we discuss and if we just go to the wavelength part of stress vegetation, where in the red band it is little bit on higher side as compared to healthy vegetation, and in near infrared band it is slightly low as compared to healthy vegetation. So with a very precise observation of these two specific NIR band and red band, that can be used for the derivation of a spectral indices, which is a worldwide or globally used, that is the NDVI, normalized difference vegetation index. So related to that theory part and the various finding, I will discuss in my upcoming slide also. So like this, a kind of a practical illustration with the same, and how actual that in near infrared band and visible band, specifically in the red band, the variations are there. And if we define for a healthy vegetation or a stress vegetation, like the figure define a healthy vegetation with a green color, which is full of chlorophyll, while a senescence vegetation, which is slightly yellowish to orange in terms of their color representation. So their wavelength is quite different, or you can say the reflectance is quite different in the both NIR band and visible band. And if we calculate or compute the NDVI, normalized difference vegetation index value, so for a healthy vegetation is around 0.72, and for a stress or you can say senescence crop, it's around 0.14. So using NDVI computation, we can a clear cut or contrast difference with respect to healthy and stress vegetation. So same mode of operands we have further used in various remote sensing or you can say satellite based imagery in geospatial technology. We can derive various kind of the NDVI products for various locations and define the crop condition or crop growth for particular area specific. Like this figure, the right side of figure define you where the standard spectral signature curve, or you can say the spectral signature for a healthy vegetation. So with the variations of red band and NIR band, which is mainly governed because of the pigment which are available or present in the leaf, as well as the leaf structure in terms of their layer formations, the thickness of the leaf, the mesophil tissues arrangement, then epidermal layer arrangement. So all of the structural part may simply encounter in measurement of reflectance part, and that reflectance is ultimately used for computation of various spectral vegetation indices. So in the same flow of work, we can use some ground-based instrumentation, specifically as we name as spectrodiometer, which give simply a wavelength from 400 nanometer to 2500 nanometer, or at a 10 nanometer bandwidth data set. It means a multiple data sets, or in a contiguous band we can get a data sets from here, and that information we can ultimately use to define various kind of land features, as well as we can use the varietal discrimination and the crop growth. The right side of flow chart define like healthy vision. If we use this such kind of data sets, for example, like Hyperion data sets, or you can say spectral sensor data sets, maybe you can say satellite borne, airborne, or ground observed using spectrodiometer data sets, we can define the crop growth as well as the spectral value, and that spectral value ultimately define the crop growth or crop condition for a particular location or area specific. So for the particular task of crop condition assessment, so very first we have to define that stress part. Like if I'm saying with respect to crop specific, if broadly classification, there's two type of stress. One is your abiotic stress, another is a biotic stress. Within the abiotic stress, there may be that may be because of your nitrogen, phosphorus, potassium, NPK deficiency, or maybe you can say water stress. So that is simply classified as a abiotic stress, while in case of biotic stress, that is defined maybe because of any kind of insect pest attack, any kind of pathogen attack, nematode attack. So these are all kind of biological stress. So first we have to identify or detect what kind of stress type is there. Then we can use these sophisticated remote sensing based, maybe airborne or maybe portable handheld instrument to define on the basis of reflectance value of a normal crop and the stress crop. And based on their variations in terms of their reflectance value, we can define how much stress scale is there. So that the third point is to define the quantification of the extent. So how much is the stress scale? It is low stress, moderate stress, or high in terms of the stress condition, or maybe you can say the severity level. So that can be defined based on the particular condition of the particular area specific crop. And the same information we can further reciprocate to define how much the kind of stress condition, if the severity level of the stress condition is on the higher side. So no doubt there will be ultimately reduction in terms of production basis also, and that that ultimate loss in terms of the biomass, or you can say the final economic yield part. So that kind of assessment of production loss, that can be also possible using the same satellite based or maybe sensor based or instrumentation based observation in the same context. And then also we can define which kind of stress condition, like it may be the water stress condition, or we can define specifically the drought condition or agricultural drought, meteorological drought, or if any kind of biotic stress condition is there, so that we can also encounter using the particular information. So that kind of assessment in case of remote sensing or geospatial technology, we simply generate various kind of spectral indices. So as I name few in the same slide, like NDVI, normalized difference vegetation index, vegetation condition index, temperature condition index, along with this number of indices are there in the same series, like VTCI, vegetation temperature condition index, then NDVI anomaly index. So number of indices we can ultimately use to define the crop condition, or you can say the crop stress level in terms of the severity level, low to moderate to high level. based on their values, and that values at different scale and the ranges part. In case of like biotic stress, if I want to define, or if we want to define for area specific, location specific, if any area has a kind of significant population or attack of in terms of insect pest, any kind of insect pest attack, or their number already beyond the threshold level. So using very first with the ground based information, or you can say visual interpretation, we can define like there is a problem of kind of biotic stress on the ground. Then we can the same information using the sensor, remote sensing sensor based information, like in terms of reflectance, we can further compare with their normal crop, the same type of crop, same variety of crop, then their comparison of among a normal crop to normal plant to, or you can say a healthy plant to stress plant. So we can define how much stress condition is there at the same time, or in you can say at the near time application we can define, and that information we can generate using the spectral vegetation indices, and we scale up the particular damage also. Like this is a very specific spectral signature for various kind of crops, like with terms of their color scheme as is defined this particular figure, and the reflectance values, they are also varied with respect to the visible range, the VIBGY, or you can say the from 400 nanometer to 700 nanometer. After that in near infrared also, and the short wave infrared region also. And each and every region is very much specific with in terms of that practices which we simply uh, derive from the information in terms of reflectance for the from the particular crop. Like in case of our PAR range, the photosynthetically active radiation from 400 nanometer to 700 nanometer, that is specifically defined by related to information of light use efficiency, or maybe you can say nitrogen, pigment, chlorophyll, all sort of information that can be derived from the information from the reflectance in the range of PAR value or visible wavelength. In case of near infrared range, we can further define that is main governed by the leaf structure part practices. So ultimately, how much biomass, yield, or plant density with a specific wavelength practices we can define using the particular reflectance value in the same data sets. Then in case of water, there is a specific water absorption bands are there, as it is also mentioned in the same figure. So using those information, we can define what are the water absorption bands are there. Then in case of various leaf or plant pigment, or the constituent fact parameters or constituent component like lignin, cellulose, all these specific information we can use or we can define using that particular wavelength. And if we use these particular wavelength and generate some spectral vegetation indices, so define how much that particular content are present in the same leaf or the plant. So total amount of quantification in terms of a quantitative analysis can be done using the particular wavelength in based information in terms of reflectance value, and that can be derived from remote sensing as well as from the any kind of instrument, and that maybe you can say airborne, or maybe you can say handheld instrument like spectrodiometer. Now come to the part of our same second in the lecture, the drought part. As from the title, the drought, might be you already have a well idea related to drought, like what is a drought. In most of the literature, in the social, in various print media, digital media, as well as in some of the articles also, they simply define the lack of water condition is defined as a drought condition. Yeah, it is also as we define the drought, but this is not a actual definition of the drought. The actual definition is defined in the Glossary of Meteorology in 1959, and they are defined that the scientific definition of the term drought, where each and every word they are specific meaning. For example, like as I just go through the word by word of this definition, a period of abnormally dry weather sufficiently prolonged for the lack of water to cause serious hydrologic imbalance in the affected area. So by the mean of this definition, a period of abnormal dry weather. So it means if any area which is already classified based on their climatic region or climatic zone, like in terms of semi-arid, arid region, and where we cannot outlierdly we can say it's a abnormally dry weather situation, because that area is already classified as a arid or semi-arid condition. So that is the definition is defined specifically for the abnormal weather, dry weather situation, and that should be prolonged if for a specific period, like for a period of or dry spell period of 1 day, 2 day, or maybe a few couple of days. We cannot say with a dry spell of that much of period or couple of hours we can define it's a drought situation. So this is specific definition, like at least up to a 5 day period where the specific rainfall at 1 mm in the total entire duration of 5 days. If it is beyond or it's a lower side of the particular scale, then we can say it's a dry spell. And based on the dry spell and the frequency, it's defined like what kind of drought situation, or maybe like I say meteorological drought or agricultural drought type of conditions are there on the ground. Then for the lack of water to cause serious hydrological imbalance. So like if with a 1 or 2 or with a defined number of dry spell condition, if it is exist in any location, but the same condition may not affect the hydrological condition of the particular area. So also we cannot say it is a drought situation, a long-term drought situation, or a periodical drought situation over the particular region. So the deficiency of water, or you can say lack of water condition, ultimately affect the hydrological imbalance. And in case of hydrological imbalance, it simply include the surface, subsurface, as well as the groundwater resources in the total hydrological cycle or hydrological balance part, and that is for a affected area. So it means if I'm saying that same condition persist over a particular location, so that drought condition is only for a defined area only. So we cannot say that condition is persist for any area and nearby area we can say it is also comes under drought condition. No, simply no, because of that condition is specifically for only affected area or a defined region as a spatial extent. That's why that definition is very much accurate, scientifically accurate, and define the actual mean of the drought condition. Now come to the next, the part in the same lecture, the types of drought. Based on the information in terms of rainfall or precipitation availability, as well as the water resource condition over the particular region, they are basically classified in the three type of drought classes: are the meteorological drought, hydrological drought, and agricultural drought. In case of meteorological drought, they simply define based on that amount of precipitation or rainfall received over a particular region or a particular area specific. And if the actual rainfall is significantly less than, or ultimately you can say lesser than 25% or on higher side, then it's defined a condition of meteorological drought. And if the same condition is persist over a particular location, and that ultimately defined as a marked depletion in the surface water as well as the groundwater, and that further lead up with the situation of the drying up of the lake, reservoir, streams, or surface water bodies, then these conditions define as hydrological drought situation. In case of agricultural drought, it is quite little bit different as compared to meteorological drought and hydrological drought, because agricultural drought ultimately defined based on inadequate water availability for a particular crop, or that defined based on imbalance or balance situation among soil moisture and crop evapotranspiration. If soil moisture is appropriate and crop evapotranspiration is on higher side, then situation is you can say it not little bit on higher side, but its condition not defined as agriculture drought. But in case of like soil moisture is on lower side while the crop evapotranspiration on higher and higher side of scale, so which ultimately lead up the situation of drying up of the plants or vegetation. So that situation defined as a agricultural drought. One more type of drought classes are there, which is based on timing of occurrence, like on the what time the particular drought condition simply occur on any area or region specific. In case of, if I'm saying in Indian context, out of entire agriculture land or agriculture potential production region or area, around 65 to 67% are simply classified as rain-fed agriculture. It means the 65 or 66% area solely dependent on water availability, and that is crop production totally dependent on water availability, and that are water availability through the only and only rainfall. If rain good amount of or ample amount of rain are available on the particular area, then there may be a possibility or there may be a situation of the crop production. Otherwise, with a lower side of the rainfall ability, there may not be the chances of the normal crop production, or maybe the situation of the stress crop production or lower side in terms of crop production. So these are 5 type of drought class based on time of occurrence. So very first is the early season drought. Early season drought defined when very at the start of the season, like in case of in Kharif season or monsoon period in the month of June, or maybe the first fortnight of July. If at the time, if monsoon or you can say the rainfall precipitation is not available in a wider area or at a spatial extent, that may be situation of the early season drought, and that ultimately affect the crops sown application, or even the seed sown application, because you can say before sowing irrigation, or sorry, before sowing water is not available in the crop field area, as well as the moisture, soil moisture is not adequate for a crop germination, seed germination practices. If the same condition may persist up to the time scale in terms of up to the month of July, so there may be chances of 10% to 50% of crop failure in the particular area, whereas the rainfall or precipitation may not be available because of the situation of drought. In case of mid-season drought, when the crop is up to the scale of peak vegetative crop growth stage, or they simply transform from the peak vegetative stage to reproductive phase, if the same time, if water or rainfall is not available or precipitation is not available over the particular spatial scale or region, that ultimately affect the reproductive phase conversion, or you can say the flowering stage. And that flowering, if the flowering stage is affected, it's ultimately affect the economic yield of the particular crop or particular area specific in terms of totality. In case of late season or terminal drought, when the rainfall are deficient at the time of the final, you can say the maturity stage or senescence stage, then it's ultimately affect the final total biomass or total economic yield of the crop, and there may be chances of up to the 50% of the crop loss or the final economic yield loss because of this late season drought. In case of apparent drought, when any area has normally has a above a 1000 or 1500 mm of rainfall on the season specific, if the same area receive lesser than the amount, the annual mean average or average amount of rainfall in the particular area or particular region, then there may be chances of like the farmers forcefully, or farmer may not be go for the same kind of cropping pattern or cropping system as he and she is following with last few years. So farmers used to cultivate another type of crops, a different type of crops, which has lower in terms of crop water requirement as compared is normal cropping pattern. So like in case of sugarcane, farmers forcefully go for the paddy crop, or maybe you can say on place of paddy crop, farmers go for the soya bean, or maybe other type of crops like maize crop. So based on the lower side in terms of crop water requirement. So that a kind of situation of apparent drought, which ultimately affect the economic status of the farmers, or you can say economic output of the farmers because of situation of the apparent drought. In case of permanent drought, where the area or climatic region is already classified in terms of arid or semi-arid region, when the particular area is not suitable for the crop cultivation, with a bare minimum rainfall, farmers or maybe the particular area specific people may simply cultivate, or farmers cultivate a type of crop which is short in terms of crop duration, as well as lower in terms of crop water requirement. So, and that kind of crop may persist if a normal or annual mean rainfall are available at the particular location. Otherwise, crop production is always on lower side, and that may be chances of lower than, you can say, 20 to 50% of crop loss because of this is permanent drought kind of situation. Now come to the part of next point, like where we I want to discuss the drought monitoring by India Meteorological Department. The IMD simply monitor the agricultural drought or meteorological drought based on the information of rainfall data sets, and they define on every 2 weeks on the real time basis for a particular season of Kharif and Rabi season for India scale. And for that, it specifically use the LD anomaly index. And for that LD anomaly index, they compute using the particular defined formula as it is there, like potential evaporation minus actual evaporation divided by potential evaporation multiplied with 100. So they scale up from 0 to 100. And while the potential for transpiration simply compute using the Penman formula, and while actual evapotranspiration compute by Thornwett water balance technique. When they scale up with multiplication of 100, so if the values are lower, or you can say on negative side, 0 and negative side, that is a situation of a normal condition or non-arid condition, while higher side of LD anomaly index value, that is situation of lead up in terms of aridity, or you can say mild arid to moderate, and further if value is higher than 50, it's classified as a semi-arid situation. Now this is one kind of indices, spectral indices, or you can say nowadays people are using satellite based data set also, rainfall data sets or physical data sets, and compute SPI. But earlier people are using that same kind of indices, standardized precipitation index, for using the rainfall data set, point observations, location specific observations of long-term rainfall data sets, and compute SPI. And that SPI is mostly used indices at the global scale to define the drought situation over a particular region or particular area specific, and they are solely dependent on the rainfall data sets. Like the formula is defined, SPI is to computed using xi minus x bar divided by sigma, where xi defines the rainfall a particular period, which we simply consider for a area specific, while x bar defines the mean rainfall and sigma defines the standard deviation of the data sets long-term basis. And if we classify like based on the particular range, if the value is on the higher side, on positive side, then there is situation or the normal situation, while if the situation while the SPI value is on the more in terms of negative value, more the situation of the drought, as it is defined by the US National Drought Mitigation Center, and they classify that particular drought severity level from D0 to D5, while the value is minus 0.5 and above, this is situation kind of normal situation or no drought situation, while more the negative, it's lead up with the situation kind of from abnormally dry to moderate, then severe, extreme, and exceptional drought situation over the particular wide area. So up to that, like using that, if we use only a ground based information, like in case of SPA data set, or you can say the rainfall data sets, so that information simply define only location specific variability, because it's a simply point scale observation or a location specific information. While if we want to define for a spatial variability over the particular region, over the particular area, then we have to use a combination of not only the ground based information but also remote sensing. Just this special technology we have to incorporate for generation of the various regional level to national level, or maybe local area specific maps in the same context. So for that, a various kind of studies are already done in our department also. IIRS also lead up in the same theme, same area, where we use various satellite data sets, satellite product, remote sensing to define the drought situation in terms of drought assessment, and the part of the variability analysis in terms of spatial temporal scale for various location at the pan India level. So for that, there are number of work or research study we are already done. So I just go to one by one related to the case study and the methodology part, how we compute and how we can how we further interpret using the particular result. And if anybody want to work in the same thing, so they can follow up the research thing with a defined or schematic methodology part. So very first, the VCI, like as I already discussed related to NDVI. NDVI is a normalized difference vegetation index, which is defined, is a kind of a proxy of crop figure or crop condition. So using the scaled information of NDVI, we further generate the vegetation condition index, which is also a globally accepted and widely used in spectral indices to define the agricultural drought or crop condition over the particular region. So for that, we have to use a historical or long-term data sets, and for the generation of the NDVI maximum and minimum value, and with a comparison of a particular month or particular time specific, like if I am using the MODIS data sets, which is simply 8-day composite. So particular same 8-day composite of specific a historical or long-term maximum minimum value of NDVI we have simply used and define the VCI over that particular location. So the formula as it is given here, like vegetation condition index, the NDVI minus NDVI minimum divided by NDVI max minus NDVI minimum, multiply with 100. If we multiply with 100, the scale up enlarge from 0 to 1 up to 0 to 100. Then where our NDVI max and NDVI minimum define the historical or long-term maximum and minimum value with variation of pixel by pixel with the entire study period. Like if I are using, for example, we are using MODIS data sets, and MODIS data sets are available from 2000 onwards, and now it's 2022. So around 22 years data sets we have using MODIS sensor data sets. So out of total 22-year specific pixel by pixel variation basis maximum and minimum value for our respective study area, and with a particular time specific the individual or a time specific NDVI value we are using here in the formula, and define the VCI with respect to particular month or particular 8-day composite using, or maybe 16-day composite with respect to particular data sets. If we further classify the data sets, the range, the lower the VCA range, define the more in terms of the drought, agriculture drought situation, because that is a kind of proxy of agriculture crop condition or crop growth. So a 0 to 25 scale up to the value define the severe drought, while 25 to 50 define the moderate drought, and higher than 50 VCA value define the normal situation over the particular region. So this is a one kind of study we did for Marathwada region up to a block level for computation of VCA, where we use MODIS data sets for 15-year and 16-day composite of 15-year of data sets. And as I just for the showcase, here I just show you from 2001 to 2012 the image as defined, the name as A, B, C, D, E have defined the 16-day composite with respect to our Kharif season from the respective month of July, August, and September. So with each and every data sets, year specific or maybe even the 16-day composite specific, we can define like how much VCI values variations are there in the respective image. For example, in case of 2002, which is we already have a qualitative idea or quantitative idea also, that 2002 is one of the severe drought in the last 100 years, in last century. So you can easily find out at the end of the September month, the maximum area, the Marathwada region colored in terms of reddish, which is from the legend we can define it as a class of severe drought situation in entire area. Like this also, if we compute in the same fashion using maybe 8-day or 16-day composite or maybe a monthly scale data sets, we can also define what is kind of the situation of the early season drought, mid season drought, or late season drought also in the same our respective area. So this is one of kind of study for the VCA computation using long-term satellite data sets, like as here we use MODIS sensor from 2001 to 2015. Now the next work, which is related to the estimation of the duration of agriculture drought, which is a very important parameter factor to define. Like more the duration part of agriculture drought, more the situation of the economic loss in the crop or in the crop production region. So here in case of estimation of the duration of the agriculture drought, we simply compute VCA data sets from the same MODIS sensor data sets, and we further convert in terms of binary VCI maps. Lower the VCI value in terms of lower the VCI value which has lesser than 50 value, we classify as 1, and rest of the pixel or rest of the part of the image we classify as 0. So it means where is the 1 in the data set in terms of binary VCI map, there is a situation of the drought in the image, and we use the respective formula. The capital D is define the drought duration in the agriculture drought during the particular Kharif season, which is a total 16 multiplied summation of I1 to n with small di. While the small di define the drought maps of each season, like here we compute one from very each and every year specific from 2001 to 2015. So for the particular, if I want to compute for 2001, I simply use all the 6 image and simply convert in terms of binary VCI maps and multiply, add on all 6 image and multiply with 16. Why we multiply from 16 here? Because here we are using 16-day composite of multi-sensor data sets. So if we multiply with 16, it's defined, it's a kind of representation of daily scale in terms of daily time scale in our legend. Like same legend also defined the drought duration, that's duration in terms of days, and that scale defined from 0 to more than 80. So where is the brownish color or orange color, which is defined more in terms of drought duration, or which is ultimately derived from the binary VCA maps. Like in case of Marathwada region in 2001 also, 2008 also, but are more in terms of drought duration as compared to the eastern part. So like this such kind of finding or interpretation we can frame using this particular kind of work, like duration of agriculture drought. More the duration, more maybe the situation of economic loss on the particular crop specific, area specific. Now the next, which is related to the estimation of frequency of agriculture drought, where the same we use the mean VCI stack layer image on the year specific, and here we use the particular formula, the drought frequency, which is also a significant parameter to define how frequently the particular area persists the drought situation. If the frequency on higher side, it means sorry, year by year that particular area persists the situation of the drought over the time. So it is very important to define which area has higher side of frequency. So the same information further used by various government agency also, as well as the policy maker also, to define like more the frequency in terms of area or persistence of the drought situation on the area. So they make a kind of government work like in terms of water reservoir, water harvesting, rainfall water harvesting, such kind of in terms of structure part also, as well as the canal formation, as well as the lake or stream formation in the particular area specific. So for the particular computation of the frequency of agriculture drought, here we specifically use the particular formula as it is given in the third slide. While frequency is summation 1 to 15 and summation 1 to 6 with VCI binary maps. And our VCI binary maps is none other than, which is we already defined you in the previous slide. Like this is the binary VCI maps of our 16-day composite data sets. And now here we define the summation 1 to 6. It means that define our 6 scene with respect to 16-day composite of 2 image from July, 2 image from August, 2 image from September, and summation 1 to 15 define like here as we use 15-year data sets 2001 to 2015. So that is the summation of 1 to 15. If we compute in the same fashion using the particular formula, we ultimately generate the drought frequency maps of the particular our defined or desired study area. Like this work we did for the Marathwada region. So this is the drought frequency map of the Marathwada region. So you can easily find out where is the color of orange and red, which is higher in terms of frequency in years, like out of in 15 years, 2000 to 2015, that area more in terms of frequency or frequent in terms of drought persistence over the time. Like we can easily identify like the area of Aurangabad, Beed, Latur, and few part of Usmanabad also, as it is higher in terms of drought frequency as compared to the our eastern part of the same area, like the area of few parts of the Parbhani district, then Hingoli, and so these districts are quite lesser or lower scale in terms of drought frequency as compared to the western part of our study area, which is comprises the Aurangabad, Beed, Jalna, and Latur, and few parts of Usmanabad also. So in the same series, next work as I want to define you related to the combined drought index for agricultural drought assessment. And this work we did for the Bundelkhand region of Uttar Pradesh. And this is the very first kind of study we did for Rabi season drought. Like earlier up to 2016, if you go to the part of literature also, the drought manual was released by Department of Agriculture or under the Ministry of Agriculture and Farmers Welfare with a supervision of the MNCFC, Mahanobis National Crop Forecasting Center. So we choose the particular area. Why we choose the particular area? Because the same Bundelkhand region is also classified and defined as because of its persistence nature of the drought over the year by year. So we want to define is the situation is the same in case of Rabi season also. So we did this study for Rabi season agriculture drought assessment part over the using the long term or historical data sets. So this is the ultimate flow chart of the same work where we use we use basic inputs like MODIS NDVI data sets, then MODIS LST land surface temperature data sets, CRIPS rainfall data set which is has 0.05 degree gridded data sets of rainfall, then ERA interim soil moisture data sets which has 0.5 degree gridded data sets, and using that particular data set we further extract our area specific result, rescale, reclassified and generate the following spectral indices which is vegetation condition index from NDVI, temperature condition index from the LST, precipitation condition index from the rainfall, and soil moisture condition index from soil moisture data sets. Then we ultimately use MCDM multi-criteria decision making approach, and where we use analytical hierarchical process and define the weightage based on their pairwise metrics and define the drought severity map, and ultimately make a comparison with the crop yield anomaly using the same Department of Agriculture, the Ministry of Agriculture Farmers Welfare data sets from their already defined already webcast the repository of the crop yield or area specific data set and define which first generate the crop yield anomaly, and we make a comparison with the combined drought index or drought severity map of the particular area specific. So ultimately we generate the analytical hierarchical procedure derived combined drought index, where we ultimately define the pairwise matrix their coefficients and multiply with their respective coefficient of with all index VCI, TCI, PCI, and SMCI, and compute CDI, and finally we generate the CDI combined drought index map. And this is just a showcase of a normal year with a drought year with respect to normal year, and with their scale, the legend part I define the extreme level to normal level with the particular area. As we did the study from 2000 to 2015 data sets, 15 year of data sets. So same year specific gram or because as we did a study for the Rabi season, the winter season crop. So as available data sets, long-term available data sets are only for the pea and beans and for the gram crops only. So using those data sets, long-term data sets, we generate the yield anomaly with respect to normal year or with respect to all the years, and we make a final a correlation between our our crop yield anomaly as well as the combined drought index value, and we find out a significant result for all respective 7 districts where our coefficient of you can say the correlation part is on higher side of 0.7 with a level of significance of at 1%. And with the figure also you can easily define or easily can make interpretation like in normal year there is a maximum with respect to all the districts there has a positive crop yield anomaly, while in terms of drought year there is a negative crop yield anomaly. And when we ultimately make a correlation with respect to AHP derived CDA, and we find a very significant correlation between them. So this is defined the potential use of the remote sensing and geospatial technology, where we can use the historical or long-term data sets and define the condition, what are the condition over the spatial scale or long-term scale, or you can say in terms of spatial temporal variability over the particular area specific. In the further, we did one project related to the drought vulnerability assessment part, which is very much important because most of the people or most of the researchers they define agriculture drought situation in terms of assessment and monitoring part, but not in terms of vulnerability part, because when we want to compute in terms of vulnerability part, you have to incorporate some socio-economic data sets also. So in this pilot project, we ultimately derive the agriculture drought vulnerability index, which is a combination of sensitivity index, exposure index, and adaptive capacity index. And these three all index are also a combination of various satellite derived as well as the socio-economic data sets based product, and ultimately compute these three indices. Like in case of sensitivity index, we compute the coefficient of variation of integrated NDVI, range of integrated NDVI, drought duration, drought frequency, and elevation, with a combination of all these 5 indices with a normalization matrix also. We ultimately compute the sensitivity index with a scale of 0 to 1, or we can say 0 to 100 only. Then in case of exposure index, we integrated the standardized precipitation index and rural population density and defined the exposure index. In case of adaptive capacity index, where we ultimately use the socio-economic data sets at the block level of the Marathwada region, because as we did this study for Marathwada region, so uh, we collect the data sets at the block level. Around 78 blocks are there in the Marathwada region. So we collect all the data sets in terms of or in category of the socio-economic parameters, where we incorporate the percentage of agricultural labor as with respect to total workers, then literacy rate, percentage decadal variation in terms of groundwater, surface water, as well as the population density and literacy rate also. Then percentage change is small and marginal land holding in terms of their area, how much area is increase or decrease in terms of block level. That area also we incorporate in the same adaptive capacity index computation. Then percentage of irrigated area to total cultivable area. Then standardized water level index, how much water level are the water table are depleted, and if it is depleted, how much level it's depleted. So all these data sets we are incorporated in terms of adaptive capacity index. And we finally are ultimately compute the ADVI, Agricultural Drought Vulnerability Index, which is summation of the sensitivity index plus exposure index minus adaptive capacity index. And why it is minus in the adaptive capacity index? Because adaptive capacity index ultimately make the system capable to cope up the situation of the vulnerability over the particular area in terms of agriculture drought situation. So as we did this block level, because these all are a respective adaptation boundary of the block level of Marathwada region, so we generate the sensitivity index, exposure index, and adaptive capacity index map using the respective integrated data sets, and ultimately generate the agriculture drought vulnerability index, where we classify as the legend. You can easily find out the vulnerability in terms of their scale basis, and we already normalize the data sets when we integrated and ultimately define the ADVI maps. So we can interpret from the result also, like the block level. So the area of Aurangabad, Beed, and Latur, where the few blocks are very highly vulnerable as compared to the other blocks, where few parts of or few blocks of the Beed, Latur, Aurangabad, and has also classified as a highly vulnerable, while the area of Hingoli, the Parbhani, these are few parts of Usmanabad, which is quite, you can say, moderate to less vulnerable as compared to the remaining other area of the Marathwada region. So such kind of study was done to define the agriculture drought vulnerability, so the vulnerability scale of the particular area specific, to define the scale of vulnerability, as well as to define the agriculture drought situation assessment part over the particular area specific. Sorry. Now come to the next, which is the NADAMS project related. The NADAMS is a National Agriculture Drought Assessment and Monitoring System, which is a brainchild of NRSC, National Remote Sensing Center, Hyderabad, part of ISRO. So very first they framed the part of methodology related to the agriculture drought assessment at the state level, district level, and sub-district level, and they ultimately covered 17 states of India, and which is predominantly agriculture region or agriculture potential production region, and they are also prone to drought situation. Now MNCFC, the Mahalanobis National Crop Forecasting Center, Pusa campus, New Delhi, which is well take care about this the same, and continuation with the instruction of Government of India and Department of Agriculture. So they are carried out the same assessment of the agriculture drought situation using not only ground information but also satellite derived informations, and define the drought situation or the drought condition in terms of drought assessment and monitoring part. So in the same context, they already published a drought manual, which is named as a new manual for the drought management 2016, which is for drought assessment, where we define the drought situation, and these specific criteria and categorization are already done to define the in terms of trigger 1, trigger 2, and ultimately situation on the what are the situation on the ground, and their classification, categorization, like in terms of severe drought, moderate drought, normal drought situation, based on information of the impact indicators. So these all are information they integrated to define the agricultural drought over the particular region at district or sub-district level, tehsil level. So in the same context, I will just go through one by one. What are the steps are as they are following up to define the drought situation over the particular up to the level of the sub-district level. So very first, the mandatory indicator. The mandatory indicators are those indicators which are compulsory to define the drought situation over the particular area, and that is solely dependent on the rainfall data sets. So in the mandatory indicators, they use rainfall data sets and they compute rainfall deviation, standardized precipitation index, and dry spell data sets. And they generate a combination, or you can say the conditions, a matrix which is defined that trigger one situation. Like in case of like the scanty rainfall or deficit situation where the value is lesser than -1, or with a add on with the situation of the dry spell, that is the situation of a drought trigger condition or a drought trigger set of condition. While in case of our normal rainfall or SPA condition which is higher than -1 value, but if the situation of the dry spell is there, then this is also a situation of drought trigger situation, drought trigger set of condition. In case of the remaining part, that is the situation of with a condition of the no or a least situation in terms of availability of rainfall, or maybe you can say that no dry spell condition, that is situation of not a drought trigger set of condition. But if the situation is a drought trigger set of, then what the next step is there. So for the next step, then they have to compute the impact indicator. So here that's why it is mentioned to assess if the first drought trigger is set off, then they have to compute the impact indicator, and this is the matrix of the impact indicator, and that defines the situation of the drought trigger 2. If the drought trigger 2 set off, then it is the situation of the ultimate, that third steps, which is for ground truthing and local area information, local area data collection. In case of impact indicators, there are several indicators. Like in case of mandatory indicators, there are already defined the rainfall deviation or dry spell data sets. But in case of impact indicator, they use a lot of data sets. They are not only use the agriculture or remote sensing, but they are also using the ground-based information in case of like soil moisture, hydrology data sets. And in the same, like in case of agriculture, they are very first define how much area is already crop zone area there. Using remote sensing, they ultimately derive the NDVI deviation or VCI, vegetation condition index formula, or sorry, condition index informations. In case of soil moisture, they compute the percentage available soil moisture condition as well as the moisture availability index. In case of hydrology impact indicators, they compute the stream flow index, reservoir storage index, the surface groundwater index. So all sort of index based on ultimately define the impact indicator as classified the impact indicator and define the drought situation. If the situation are persist, impact indicator and the condition of that, like this is a situation of the drought triggers 2 set off, and what are the next step, that is to define the intensity of drought using the particular information of the impact indicator. So very first, if the situation of when the situation is come or defined as a drought, severe drought situation or moderate drought situation or normal condition, if out of all impact indicators, like if all selected 3 impact indicators are in the severe category, like as we defined in the previous slide, there are the total 4 impact indicators. Out of 4 impact indicators, if 3 impact indicator classify as a severe category, so this is a kind of situation of the severe drought. If out of 3 indicators, they are 1 or you can say 2 defined as moderate or severe class, and it's a situation of the moderate drought. In case of normal, if all other cases are there, that is classified as a normal situation in terms of intensity of drought based on the information of impact indicators. So if the drought trigger 2 set of situations are there, then now the condition to find out is the level of severe drought or moderate drought. Then step 3 come into the picture, like the final determination can be done, and final determination has to be done using the sample survey with ground truthing data sets. Like what is the actual situation on the ground? So that ground truthing data sets that define the spatial extent in terms of variation of severity level as well as the scale of the drought, that can be also defined with a ground truthing data sets. So like this is our total 3 steps. Very first is the mandatory indicator, second is the impact indicators, and third is the final determination using the ground truth data sets. So this is the whole soul basic approach of MNCFC to define the drought assessment part, and that is already defined in the drought manual. You just go through, you can use as a make a reference also using the particular drought manual and define any area specific, which is you can say more in terms of persistence of the drought. So you can define, or you can use the same methodology and define the drought situation of the particular area. Now the next step in the same lecture, I want to discuss about the global products. There are various global products which are readily available at the global scale. Might be the spatial scale or spatial resolution are different, but they readily provide you the various spectral indices and their respective products, which you can easily visualize. You can analyze also, and you can directly download. And these downloaded product you can also use for any area specific scientific study. So in the same series, very first product is the Global Drought Information System by US government, and that they define the drought monitor. They also generate the product of the S1 month SPI, 2 month SPI, 3 month SPI, and vegetation health index map, which is a integration of VCI and DCI. And this is a global product which you can easily visualize over the pan India, and you can also download the particular year specific data sets. The next kind of product is the drought monitoring system, that under the umbrella of IWMI, which is a international water management institute situated in the Colombo, Sri Lanka, and they are working on the water management aspects. And there is a specific one section which are our project where specific system work on the South Asia drought monitoring system, SADAMS. And there this is the user interface or their website of drought monitoring system, the DMS, where you can see and visualize the data sets of 8-day composite using the, as they use MODIS data sets, or so you can directly see the data sets. Directly you can visualize the data set. They also scale up, categorize the data sets with the entire range of the data sets. So you can easily see the 8-day, monthly, and seasonal data sets, as well as you can download the data sets in terms of only map form, just to analyze with your area specific. The next product is from the University of California, where they specific generate a product which is GID maps, the Global Integrated Drought Monitoring and Prediction System. And the drought indicators, there are 3 types of drought indicators as they illustrate in their website. This is one is the standardized precipitation index, second is the standardized soil moisture index, and third is the multivariate standardized drought index. So these all data sets, these all drought kind of drought indicators you can visualize on the particular GID maps, use web page, and also you can download the particular map. The next is the SPEI, standardized precipitation erodic index, and these products are also in global scale. You can easily see, and that kind of product which are available from 1901 to till 2020. You can see the data sets, the variations of SPEI, because as compared to the other kind of meteorological drought or meteorological drought indices, SPEI is one of kind of significant index which define drought situation more significantly, more qualitative manner. So this SPEI product directly you can visualize from the particular web page. You can download also, and you can use for the further study. So this is all kind of global products are there, which are freely available or readily available, which you can use for various kind of spatial temporal studies, and or you can download the particular data sets. So this is all from my side. This is the particular lecture as I compiled using the research study of our IIRS, ISRO, various national and international website research studies, and the study material of our same department, agriculture and soil. So thank you from my side.